In Chapter 3, we will start doing some statistical calculations. And the first thing that we are going to look at is what is called measures of central tendency. And this deals with your different types of averages is what this means. Central tendencies is the same thing as your averages. And the three we're going to look at are mode, median, and mean. So the first is the mode. The mode is the value that occurs most frequently in a set of data. The median is the middle data value or the average of the two middle data values. It just depends on how many total numbers are in your original set. The other thing with the median that we will look at, and that is finding the position or the location of the middle value, and that is found by taking n plus 1 divided by 2, and n equals your total data values. And then the last measure of central tendency, or the last average we look at, is the mean, which is the sum of all the data values divided by the number of data values. And if you'll look here, I've got sample mean and population mean. And if you recall, the difference between the sample and the population is samples when you use all or every person or item in the study, and this excuse me, the sample is just a portion of that. Now there is some symbols you need to be aware of. X bar is what is representative of a sample mean, and remember this numerical value then would be a statistic because the numerical measurements that go with the sample are a statistic. And this symbol right here is called mu, and this would be a population parameter. Sample statistic, population parameter. This symbol right here means the summation. It just says to add up all the x values, divide by the total number of values. The same formula would be used for population. It's just that we do not typically have to calculate the population mean. What we will calculate is the sample mean. So let's take a look at 3 examples that I have down here. I just wanted to do some small sets of numbers so we could get familiar with this. So I look at this first set and I say, okay, there's 4 values, so n would equal 4. The other important thing you need to do is always put your values in order from the smallest to the largest. If you do not, then you will incorrectly calculate the median. So I'm going to rewrite these numbers. It would be 3, 3, 7, 8. So now we're going to look at first what is the mode. The number that is most frequently listed is your 3. So my mode is 3. Now what we're going to look at is the median. And the median is basically the middle number. So just to get you used to, we're going to look at how to calculate the location of the median. So the location of the median is this formula right here, n plus 1 divided by 2. Since n is 4, there are 4 data values, we would put 4 plus 1 divided by 2, and that equals 2.5. Now here's where you need to be careful. 2.5 is not my median. 2.5 is the location of my median. So what 2.5 tells me is that the actual median is located between the second and third number. So 1, 2, 3, 4, this is your second, this is your third number. So my median is located between these two. So in this particular example, to find the median, we will add 3 plus 7 divided by 2, which will give us, oh, I had 2 equal sign, which will give us 5. So we have the mode is 3, the median is 5, and now we're going to calculate the mean. And since we will, the majority, if not all of the time, only calculate the means for samples, I'm going to label this as X bar, which is a sample statistic mean. And here we will add all of these values up. So 3 plus 3 plus 7 plus 8 is 21. And I divide by N, which is the number of data values, which is 4. And that calculates to 5.25. So for this particular set of values, my mode is 3, my median is 5, and my mean is 5.25. So now we're going to look at the second example. There are 1, 2, 3, 4, 5, 6, 7, 8 numbers, and I'm going to put them in order so I can correctly calculate the median. So I would have 2, 3, 5, 5, 6, 8, 9, 9, 1, 2, 3, 4, 5, 6, 7, 8. So I have all 8 of them. So the first thing I'm going to list is my mode, the value that is listed most frequently. Well, when I look down here, I go, well, there are 2 5s and 2 9s. So in this case, my mode is going to be the 5 and the 9. So it is okay, and sometimes you will get multiple modes. Now we're going to calculate the median, but before I do, I want to find the median's location, which is N, 8 plus 1 divided by 2, that would be 4.5, so it tells me that the median is between the 4th and 5th number. And the reason that is because on a number line, 4.5 or 4.5 falls between 4 and 5. So 1, 2, 3, 4, 5. So my median is between the 4th and the 5th number. So my median is 5 plus 6 divided by 2, which is 5.5. And then the mean, you will add all of these numbers up, which is 47. There are 8 of them, so we'll divide by 8, and that gives me 5.875. So here's my mode, my median, and my mean. Now, for my online students, be sure and pay attention to WebAssign. On an answer like this, it may say out 3 decimal places. If it says to go out 2 decimal places, use normal rounding rules. If it says to go out 1 decimal place, so be sure and pay attention to the directions on WebAssign. All right, so this last example, there's 1, 2, 3, 4, 5, 6, 7 numbers. So N equals 7. And it looks as though they're already in order, but I'm going to go ahead and rewrite them just because it's a little bit easier to see when they're in 1 row instead of 2. So my mode is the number that is listed most frequently, and I look down here and there is not any number that is listed more often than another. So that tells me for this particular example, there is no mode. My median, well, I first want to know its location, and N is 7, so 7 plus 1 divided by 2, that is 4, so it tells me it is the 4th number. So that makes it really easy. 1, 2, 3, 4. My median is 10, and then my mean, which again, and I didn't list this on the last example, but I'm going to call that X bar just so you guys can get familiar with the symbols. And we will add all of these up, which is 78 divided by 7, which is 11.14. So we have different scenarios, and those are their calculations. So now we're going to apply all of that to these examples here. All right, so this first example, it says, in a course entitled Experimental Psychology at Regis University, students train white rats to do various tasks based on a performance reward theory. So one event is the hurdles. All right, so we have these little rats jumping the hurdles, and this is how many seconds it took them. So we have 1, 2, 3, 4, 5, 6, 7. So I know n is equal to 7. And then before I start calculating my central tendency or my averages, I want to put them in order. So I'm going to rewrite them from least to largest. So 1.8, 2.3, 2.8, 2.9, 3.3, 3.3, 5.2. Get that just a little bit larger. All right, so we're going to calculate the mode. And I look up here, and it's very easy to see that 3.3 seconds is listed twice, so that would be my mode. The median, which will be the middle number, well, I'm first going to find its location, which is n plus 1 divided by 2. So 7 plus 1 divided by 2, which gives me 4, so I know it's the fourth number. 1, 2, 3, 4. So 2.9 seconds is my median. And then the mean, we're going to add all of these values up, which is 21.6 divided by the number that there are, which is 7 of them, and I get 3.09 seconds. So there are your measures of central tendency for the hurdles. We come down here, and now those little rats are going to be climbing a ladder. And so once again, it's in seconds. 1, 2, 3, 4, 5, 6, 7, 8. Now we have 8 rats that climb the ladder. And again, I'm going to put these numbers from smallest to largest. So 5.1, 5.5, 6.6, 6.6, 6.9, 7.7, 7.9, wow, 41.9. All right, so the mode. So I look here, 6.6 is listed twice, so it appears my mode is 6.6 seconds. My median, its location will be 8 plus 1 divided by 2, which is 4.5. So it tells me the median is between the 4th and 5th number. So 1, 2, 3, 4, 5. So 6.6 plus 6.9 divided by 2, which is 6.75 seconds. And now my mean, and I didn't do this in the last example, but I'm going to put that X bar there just so we get familiar with that. Add up all of these numbers, and I get 88.2 divided by 8 values, and I get 11.025 seconds. This central tendency is way different than these central tendencies. And hopefully what might be a little red flag to you is go, I wonder if this 4.9 is what caused that, and that is correct. This number that is way different than all the others is what we call an outlier. An outlier is a number that is way smaller or way bigger in comparison to the rest of your data. But the outlier does not affect the mode, it does not affect the median, but it definitely affects our mean. So that leads us into, sometimes we will trim our mean to get a more accurate mean average, because that one was a little off. So let's talk about what the trimmed mean is. the mean of the data values that are left after trimming or getting rid of a specified percentage of the smallest and largest data values from the data set, used to eliminate extreme data values, which are our outliers. The numbers must be ordered from smallest to largest. So here's what it's talking about. This example says we have 100 data values, so it's telling us that n is 100 values. So if we were going to look at a 5% trimmed mean, that tells me that I will delete the bottom and top 5% of the data values. So we multiply n times 5%, and that gives us 5. What that tells me to do is to trim the 5 smallest numbers and the 5 largest numbers. So we trim a total of 10 numbers. Then we take the remaining 90 values, add them all up, and divide by 90. So the same concept is done when you look at taking a 10% trimmed mean. We're going to delete the bottom and top 10%. So we take n times 10%, and it gives me 10. So that tells me to trim the 10 smallest numbers and the 10 largest numbers. So we're going to trim a total of 20 numbers, and then take the remaining 80, add them all up, and divide by 80. Now, you'll always do a 5% or a 10% trimmed mean. You're not going to do anything weird like a 7% trimmed mean. All right, so down here we have an example. So we have a sample of 20, so I know n equals 20. Gymnastic classes in Oklahoma showed class sizes to be. So we had a gymnastics class of 8 students, all the way up to 85. So this says to calculate the mean, the 5% trimmed mean, the 10% trimmed mean, as well as find the median of each. All right, so we're going to start out with all 20 values. So we're going to look at calculating the mean and the median when n equals 20. All right, so the first thing I'm going to do is calculate the mean, or my x bar, which tells me to add all of these numbers up, which when you add them up, you get 729, and you divide by all 20 values, so you get 36.45. So there's my mean for all 20 values. We're also going to calculate the median. So the location of that median will be 20 plus 1 divided by 2 is 10.5. So that tells me it's between the 10th and 11th number. So I come back up here and I go 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's my 10th and 11th number. Because, by the way, these were already in order from smallest to largest. If they weren't, we would have needed to do that first. So 31 plus 34 divided by 2 equals 32.5. So when n equals 20, you're using all 20 values. Here is your mean, here is your median. So now what we're going to do is we're going to do a 5% trimmed mean. Whoops. On those 20 values. All right, so in order to find the 5% trimmed mean, we have to trim the top and bottom 5% of the data. So we take n, which in this case is 20, and we multiply it times 5% or 0.05, which gives me 1. Now what this tells me to do is it tells me to trim 1 at the bottom and 1 at the top. So what we do is we trim a total of 2 numbers. So now n equals 18. So now what we're going to do is we're going to find the mean, or x bar, sample statistic, on those 18 values. So you'd add up all the numbers, you're going to eliminate the 8 and the 85, and you get 636, and we're going to divide by 18 now because we're only looking at 18 of the numbers, and it gives me 35.3 repeating. And the median then, to find the location of the median, we now have 18 plus 1 divided by 2, and that is going to be 9.5, which tells me that it's between the 9th and 10th number. We'll look up here, because I've eliminated this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 9th and the 10th is that same 31 plus 34 divided by 2, which is 32.5. So the median was in the exact same location. So the mean changed, but the median did not. All right, so now what we're going to do is calculate the 10% trimmed mean. Now, when we calculate the 10%, when we want to know how many numbers to eliminate, we go back to the original 20 numbers. So I take the 20 numbers times 10%, or 0.1 or 0.10, which gives you 2. So what that tells me to do is to trim 2 numbers that are the smallest, and 2 numbers that are the largest. So that tells us we're going to trim 4 numbers, and I'm left with 16 values. So to calculate the mean, or the sample statistic, x bar, we're going to add those 16 numbers, which is 537, and divide by 16, which gives me 33.5625. And then the median, its location, will be 16 plus 1 divided by 2, which is 8.5, which tells me it is between the 8th and 9th number. So I come back up here. These 2 are trimmed. 1, 2, 3, 4, 5, 6, 7. There's the 8th and the 9th number. So my median has remained the same. So the trimmed mean has affected my mean, but it did not affect my median. So that's one thing to pay attention to. Now, one other thing that I want to point out is I have done 2 examples, one when n was 100 and one when n was 20. And what has happened is every time you multiply it times 5% or 10%, you've gotten a nice, neat whole number. But what happens if n is equal to 56? Well, here's how you handle that. If you were doing a 5% trimmed mean, you would take 56 times 0.05, and you get 2.8. Well, you can't trim 2.8 numbers on the bottom and 2.8 numbers on the top. So you use normal rounding rules, which would be 3. So that tells me to eliminate the 3 smallest numbers and the 3 largest numbers, which in essence means you're going to trim 6 numbers. Now, if you had, say, n equals, let me see, trying to come up with a number. Okay. Oh, before I do that, sorry, let's do the 10% here. Because down here I'm going to do n equals 121. Okay, but before I do that, I do the 56 times 0.1, which is 5.6. So that normal rounding rules would tell me to round that to 6. So I would trim 12 numbers. Now let's look if n was 121. So the 5%, 121 times 0.05 is 6.05. Well, in this case, normal rounding rules would be 6. So I would trim 12 numbers. 10%, 121 times 0.1, you are going to get 12.1. Normal rounding rules, that would be 12, so we would trim 24 numbers. So that's how you handle it in the case that you don't have nice, neat numbers that come out to whole numbers. So that completes 3.1.